Okay, does that sound okay? Sounds all right from here. Everybody can hear me? Okay. I'm going to talk about finalizing a small standard. The synopsis is it's about refining an XSLT extension library to 1.0 status. And I'm going to talk about the reflections on that experience. This is not rocket science. You can switch your brains off for a bit. It's more about what happened, the types of major issue that appeared, and some lessons and some unsage advice. One footnote is, I'm talking here, I use XSLT. It's actually for XPath, XQuery, but my world is XSLT, and that's what I'll, when I say XSLT, read the others in. Right, standards, the more the merrier. We've heard a lot over the last day or so. We started back in '98 with XML starting and HTML4, and then there was the XSL experiment, and from that came XSLT1. And as Mike told us earlier, these have long gestation periods, 3 years to, and then another 3 years of sort of bedding down, so they come at about 6-7 year intervals down the pike. And then we're going up towards XSLT3. Now, unfortunately, for many or some application developers, they need that little bit extra. And it was very perspicacious early on that people said, right, in XSLT1, we will want to be able to, people to put their own extensions in, and people did. But then the question came about, what, could you get some commonality in terms of these libraries? And we got some notions of community spirit, and particularly the EXSLT community back in basically 2003 to 6 period, worked on some of these in a semi-formal sort of way and produced particularly the math library, which then got back into XSLT2. Actually, I think it's XSLT3 it became finalized in. And that sort of petered out, but another one started up that Florent and Georges started, what, 3 years ago, the EXPath community, which basically has worked on producing a number of standards with a rigor, admittedly on a very small scale, which approaches that W3C is trying to do, not necessarily bureaucratically, but the specifications look in similar way. They've got similar sort of standards about test suites and that sort of thing. And they did Web App 1. Now, this year, this conference last year, I wasn't here, apparently something came up about binary manipulation, and it was suggested that it might be an EXPath standard, and Jerka basically set off apparently like out of a trap and got a version drafts put together in about a month. Now, that has now got to a 1.0 status as of December, and the question was, what happened? I got involved in doing that at the behest of Mike Kay. It's not rocket science. It's 26 pure functions and 38 signatures with one main type of the base 64 binary. It doesn't do any I/O. It picks that up in bulk from the EXPath file module. It has things like generating binary constants, basic operations, bitwise manipulation, probably the most important thing, stuff for encoding and decoding strings and numbers. And the Saxon implementation is basically a single Java class with about 1,000 very sparse lines with 56 methods in it. And there are two sets of test suites developed independently that are a couple of hundred each. And that's sort of about it. It's more about how did this come about? Well, am I certified to do this? Qualified might be a better term, but certified is much nicer. I spent 25 years working at HP Labs in Bristol, and that's me much, much younger. And for the last 5 to 7 years, I've been working on document engineering. And then I actually did a PhD in this one on the work that I've been doing there. And all the work I've been doing has been on an XSLT SVG architecture, using Saxon very extensively and building extension functions for doing all sorts of interesting issues. And at least one person in this room knows exactly what I'm talking about. So I then started doing some part-time work for Saxonica last July. And the time frames were roughly this. I started on the 1st of July as to study the 12th of March spec, and look at all the previous comments, which had happened basically in April, May, to instigate some more XPath discussion, and anybody who's been involved in these knows that they come in leaps and bounds, and built an Saxon extension class and test suite and got it running, and issued a revised draft at the end of July. It was actually 10 days work, including the familiarization with the build environment for Saxonica. We then went through 2 more revisions, one in the middle of September and one in the middle of November, working our way through the different issues, which are far, far smaller than, for example, the working groups have to deal with, but they still give some interesting issues. And a final version was published on the 3rd of December. There are about 100 postings with 6 major respondents during this operation. We had sort of 3 or 4 major issues that came up, major by the size of this particular library. And it was, unsurprisingly, bursts of frantic activity interspersed with long, quiet lulls, and then thinking, well, we should push something back and getting it going. Right. And the big thing is you producing this specification, which looks like an W3C spec, but is quite a bit smaller. You have to prove the specification. You have to basically work on, is it right, is it consistent, and everything else that you need to deal with that. Now you could, if you had real leisure, you could try and do this sort of proof with mathematical, theoretical background. You do a lot of discussion. You hopefully don't have too much argument. But one of the most important things that I certainly found is you must implement it. Especially as the editor of such a thing, if you're not implementing it, you're not actually experiencing what it actually means. And one of the things that also became important to me was the notion of what I call the medium-sized example. Something that's big, not completely trivial, but big enough to put inside the specification itself and to illustrate some things. And I'll show you what I mean. The specification itself should be littered with small 1 or 2 liner examples. This is one that came up later which showed that it answered the query, in fact, that big long shifts of longer than 1 byte were seriously possible. But understanding the purpose of the specification and pieces and how they interact requires these medium-sized examples, and this is one that you'll find in the spec, which is the standard thing of how big is my JPEG? And it basically involves 2 things. One is to search the binary to find the appropriate tag field, and then to decode 2 other numbers that are at a fixed offset from the beginning of that field. Now, one of the other things we did in this was use another example, which was ASN.1 Integers that Mike suggested, which took me back a very, very long time, to some time I was working in networking 20 years ago. And this was a lovely little one, because it's quite interesting. ASN.1 is basically encoding of variable length numbers, very large numbers possibly. And it has a tag for an integer, it has a length field, and it has a series of octets. The problem is that the length field, if there are less than 128 octets, that length field is 1 octet long. But if it's longer than that, the length field itself is variable. And in fact, it can be up to 128 octets of information about how long the rest of the thing is. So it's more than the age of the universe squared. So you get 100 looks like this. 2 is the tag. One byte saying there's 1 octet which has got 100 in it. 300 basically looks like that. 256 plus 44. And 0 has no data at all. So what you do is basically use this as an example in your particular piece, and these are some pieces. It's a helper function, and this is the function that encodes, and there are some examples here. And one of the interesting pieces was I suddenly realized that I'd been working with sort of numbers up to sort of longs, and then I went into big ints, and it just carried on working. And then I said, all right, well, I'll just cut and paste a 900-digit number. And Saxonica just takes them in, pushed it through, out came an answer. I wasn't going to check it all, of course, but I could then put that back through the next piece, which was the decoder, which was a little more complex, actually, used a lot more of the features from the library. And lo and behold, the output that came back was the original 900-digit number. And went. So that had the advantage when these medium-sized examples, you may get serendipity of having testing some of the scaling issues, for example. Okay. Well, other lessons that came from them are you've got to think about the policies when you're putting these in. Policies are choices that will need to be made in several places, either in the standard itself or in a context that's wider. And for example, we came up late in the issue in this development of some cases which actually were policies for XPath itself. Okay. I'm going to go through some of these ones, 4 of these quick examples. The first one is naming of things. I mean, you've got this library of functions. They could be called F1, F2, F3, F4, or F5. That'd be fine. They're entirely separate and distinct in their own namespace, but they're not exactly terribly useful. Names have use for when people are writing things. And this is an example where the binary subsequence. This was in the original draft that Jerker put together. And one of the things about there was it became clear that things like the names of your arguments being consistent right throughout is very, very helpful indeed. So we've got here that they're all being used in the same way. But it's also useless if names become too big or redundant. In this particular case, the binary hyphen at the front, given the bin colon, was really redundant because it's all about binary. So we could drop that out. Now we've got bin subsequence. Oh, that's interesting. Hang on. There's function subsequence. All right, different namespace. But actually, the semantics aren't quite the same. The semantics of this is actually closer to substring than subsequence. It takes a binary item and produces a smaller binary item. Okay? So we could call it sub-binary. But then you have to be thinking about this. Sub-binary is a hell of an ugly word. So somebody suggested part, and that's what it became. And it worked quite nicely. It's short. It's like, you know, and we got join and equivalent like that. So you have to think about your names. Anything that's useful is going to have errors in its execution or be thrown with the things that give errors. So this was the original set of error codes. We changed them because eventually we decided that actually meaningful names for errors were better. So that's what happened in 20th September. And then by the time we got to 3rd December, we'd actually trimmed that down. One was no longer relevant. It wasn't going to happen. One, we changed the name because it was more general. And to 2 others, we basically said, actually, you don't need these 2 to be separate because you can actually choose detect which of these was the case by putting information on the error variable in a try-catch situation, at least for an XSL, anyway. The big issue that came very late in the last sort of month was what I call arguments on the edge. And this came from insert before as an example, where insert before puts binary piece inside the middle. Okay? You could put it together by parts and joins, but it's easier to have one function that does it. And the questions then came, what happened if these arguments were empty? And there were 2 senses of that being empty, one being an empty string, I bound to null, or sorry, an empty sequence, or actually an empty binary, which isn't the same thing, just as in string. And those were fine, we could handle those. The big ones were what happens when you went before and after the ends of the arrays. And we actually spent a lot of time if we got that sort of very much nailed down early on, it would have made a great deal help. And right at the end, we got this thing I called the future is somewhere else. We had this packed double, and somebody said, oh, well, can we change it to a packed double with a double star rather than just a single double? And by that time, we just had it. And we said, right, that's going to wait, too late, it's going to go for version 1.1. Then somebody said, okay, what version am I? And then, of course, we realized, how do we identify the version? System property bin or bin version or a function. And this was very late in the day, and somebody said, oh, that's too late, we'll leave that for version 1.1. And of course, you'll now understand that there's a sort of a self-fulfilling prophecy down here at the bottom. So that's actually an XPath issue as much as it is just ours. Okay, right. The other thing you should do when putting all these standards together is that you consider you're a software worker. And you're looking in declarative space, and you've got tools, so damn well use them. We're used to algorithms plus data structures in programs. An equivalent might be tools plus declarations equals specs and tests. Copy and paste is not necessarily your friend. Use it sparingly, or do not use it profligately. Think about what you want to do, and think about the consequences of what I might call imperative actions. It's much better if you can find something to put some declaration in place. And there are lots of places in these areas where there are declarations. For example, in the binary, we have the function catalog. Now, the file one before hadn't used this mechanism. And this contains a hell of a lot of stuff you can use. It contains signatures, which are used to generate the spec itself. They control summary. They contain rules, which could even be more declarative than we're seeing here, which is basically a series of HTML stages. We have sets of errors and references, and we have notes, so you can have examples and that sort of stuff. But this is a resource that you can use because pretty much all our documents, our tests, and even most of our programs are in XML. We've got the function catalog, we get Qt3 test suites, we've got the spec itself. We have a superb tool for basically manipulating this stuff. It's called XSLT. You can just pull these things together in various ways, and you did. You can expand the test sets to basically generate test sets for yourself. You can document the test results by pulling stuff through from the test results in the catalog. You can basically produce implementation documentation, which is one of the things I'm doing with Saxon for this one. And you generate the spec itself, and the man at the back there is basically, I keep seeing his name all the way back, this history of the spec style sheets and the cascading of them sitting on top of each other. Okay, the other thing you have to do is to be realistic, especially in these sort of small things. We haven't got all day. You're trying to sort of chase and give some sense of solidity for people for a year or two so they can start using it. Focus on the core, get the essential elements working first, and draft the rest in XSLT. I mean, there literally for this module, probably there are 2 or 3 essential functions. Actually, the numeric decodings probably are the ones that do need to be there very specifically. But the rest you could draft out in XSLT and then progressively move them into actual spec and into actual implementation. It doesn't have to be perfect. It has to be reasonably robust. But it doesn't have to handle everything. Not in these cases. It's enough to give enough to start this particular area off and push things and let people work on it and let both application developers and implementation developers work against that standard. There is an issue of pragmatism versus purity, which doesn't appear in this particular piece, but it does appear in the file, for example. We've done lots and lots of hard work to make XSLT pure, but there are some uses that may require side effects. And the best example, a very simple example of this would be, this is a little piece of code which is writing PDF directly from SVG by constructing little fragments in binary and then putting it together. And it's choosing, in this particular case, to use the file append onto a binary. Okay? And the problem here is that the for return need not necessarily be done in the same sequence, provided the answers are actually pulled back together. So you could find if where you wanted this graph looking like that, because some of these pieces, which were the data points, or the thing, have not actually been written in the order in which you thought they were being written. Okay. And if you really want to go down this route, I started having nasty pictures about monads and everything else, and they're saying, oh no, I don't want to go back there again, please, no. But this is an area that's going to start increasingly becoming apparent with some of these sort of extension systems. Okay. Now, acknowledgements. Jerka started this thing off. I've been helped greatly by him. Florent basically gave a lot of help, particularly in the early stages when I was new to this particular thing. The XPath community chipped in, and especially Christian Grun later on. He did the first other application implementation, and Mike Kay kicked me into doing this, and I quite enjoyed it actually. A Quo Vadis, well, there's another one on the stacks on archive format, which is basically the last main published draft is in September, and there's an editor's draft around at the moment. And we really want to try and get this one going in the next couple of months, take it close to the 1.0 standard. Similar thing, it's basically manipulating zip and archive files in particular areas. And it has an interesting issue about how we use maps or not use maps. And that's it. I'll take questions.
Does it work? Yeah.
Yeah.
I was wondering in how much you would like to pair the function signatures that you create in the binary module with the ones that are already there in XPath. You showed the subsequence as an example.
Yeah.
I happen to notice that in XPath you have XS double as
yeah.
Positions, and you use XS integer.
That was actually that was a question that I asked Mike at one stage early on, and his reply was that double comes from the days of XSLT1, where you didn't have error recovery systems, and you tried to build systems which are much more amenable, but that the general philosophy was going forward into 2 and 3 was that things that really should be integers now, and not attempt to go back to meet that, because this is never going to be running on under XSLT1. I mean, it's, you know, the archive one is questioned about whether it'll even run under parts of it will run under 2. So that was a question where a policy or a philosophy from outside, which is saying going forward, saying you know, integers, if they really are integers, then they should be integers, was something that was like part of the policy effectively, but a pretty high level perhaps an unwritten policy. Okay.
So you look to the future instead of
yes.
for backwards compatibility.
Yes,
yeah.
and you know, you're not going to run this inside a browser. You're going to be running this in server systems and generators and all that sort of stuff. So that was the philosophy we had.
Makes sense.
Thanks. Mohammed, next question.
Yeah. Very good presentation, by the way. Thank you.
I've done quite a number over the years. Actually.
You hear me? Yeah. So, how do you think this could apply to other kind of specification? Because it seems like you did something that the W3C looking for ages to do quick and agile specification production. what would be your advice?
The thing with this particular module, you could clearly see that what it needed to do was pretty simple in terms of the variety of operations that were going to happen. And you didn't need to do more. There's a question about whether some occasional convenience function was there. And so I could do that quite easily just by thought experiment as much as anything else. Okay. If you've got something much more complex, then you need to be somebody who's using that, the implementer or the editor needs to be somebody who's got a fairly keen interest in that particular application area to do it. So for example, if you're doing something on geolocation module, for example, then I would say that would have to be somebody who's got a really strong interest in basically in maps and geolocation and that sort of stuff, and a lot of background from that particular area. So I think it depends upon what people, the generality or the locality of the application area they want to try and deal with.
Another question, please.
Yeah, Dave Pawson asked from afar via Twitter, what do you mean with draft out in XSLT? Is it writing an XSL function as a stub?
Yes, it means basically using many of these things. Once you've got certain small pieces going in the extension function regime, you can write out effectively a piece of XSLT function that will do what you want to do. So, and then test that one out, and then you progressively you can spec it that way and test it that way, and then you don't, as an implementer, when you're doing a parallel one, you may or may not move it into Java or whatever you're going to do. You know, we live with that language. Just use it as much as we can. In fact, it's going to be even better because some of the stuff with packaging, we're going to start finding some of these features and functions appearing not as extension functions, but as loadable XSLT functions. And we've already got that in the proposal for XSLT 3 on its JSON to XML support. The JSON to XML is a function that has to be implemented either as an extension function or inside the system itself, whereas the XML to JSON is actually a style sheet. And it will be a style sheet package, effectively.
Okay. Thanks.
Okay.
Anyone else who wants to ask anything? No, we are done. Thank you so much, Jon.